we got to our interactive panel, Ask an Expert, and we have 5 well-known experts and moderator, James Taylor. Let's do it.
All right. All right. Thank you. Yes, I was going to say we're all on here hoping that there's some expert we can ask. But not. So the way we're going to do this is the way we've done it before. So I'm going to do a quick intro for everybody. I think almost everyone has spoken earlier in the session, apart from Carlos, who appears to be slacking. But we'll do a quick intro so you know who everybody is. Their names are on the photo, so you should be able to find them easily. Then I've asked each of them to share a story with us about, particularly one relevant to the sort of the theme, which is around like machine learning and AI in the context of decision making. So we'll get some initial like stories out there, so you can think about what questions you want to ask, and then you go ahead and ask the questions. We'll spend the majority of the time answering questions that come up, and then I'll wrap up at the end with a sort of give them a chance to give you a sort of a closing thought or a hint or two that you can take away as a sort of step. So if you want to go take a nap and just come back for the tips at the end, that's okay too. But do ask questions. Do think about questions you're going to ask. I'll filter through them. I may generalize them a little or change the words to protect the innocent, but fundamentally what we want to do here is answer your questions. So be ready. So with that, let me do introductions. I'm going to do them alphabetically by first name. So first of all, we have Alan. Alan's had a long career in human factors, business rules, decision management. He has a PhD in neural networks. He spent many years as a consultant, more recently in product development at FICO. He published Knowledge Automation, a book that I remember vividly from 2012, talking about decision requirements diagrams. And he's the co-chair of the DMN committee at OMG. So like me, must have been a very evil person in a past life because he's stuck on the DMN committee. And he's been involved, as a number of us have, with DMN since the very beginning. And today he's very focused on making the tools for decision management more accessible to business users. Carlos has spent a big chunk of his career in AI, analytics, decision management, business rules. He worked in Europe for many years, as you can tell from his very slight accent that he still has, including the European Space Agency. He joined Neuron Data, worked on one of the very early expert systems, an expert, and then Blaze Advisor from the very early days of business rules, is where I met him. He was then responsible for all the decision management technologies at FICO, and then co-founded Sparkling Logic, where he's responsible for Smarts, their decision management platform. So that's Carlos. Gary, who was the last one to join us, right on time, has been working at the forefront of business automation architecture for, like the rest of us, 30 years perhaps now. Business automation architect with Oracle. Gary specializes in research prototypes for next-gen cloud, native infrastructure, generative AIs, LLMs, object storage, event streaming, whatever cool technology Gary feels like playing with, as far as I can tell. Recently, he's been trying to generate Python code and decision models from natural language. I think you heard about that earlier. And until very recently, he was also on the DMN committee before Oracle decided they had something better they wanted him to do. Yem has been involved in decision technology for more than 2 decades. He's focused today on knowledge modeling and the business user experience. There's a theme here around helping business users use these technologies, obviously, and working with users and practitioners really to make the authoring of decisions easier. He's the decision chief architect at IBM. He's also been involved in one of my favorite projects, which is the navigation system of the unmanned Mayflower autonomous ship. I always think it's a great example of a decisioning system in action. And then last, but by no means least, Jan, who's just finished presenting with Ryan. Jan's been working in investment banking for 25 years, focused on decision automation, decision modeling, machine learning, AI. He's led lots of projects around decision modeling and machine learning together, including integrating large language models and decision modeling. He's the co-author of a fabulous book on decision modeling called Real World Decision Modeling with DMN with some hack. And the second edition of which has just been released. And he's the current chair of the DMN on-ramp committee at decisionautomation.org, as I think you just heard. So we have a great panel. Most of us have been doing this for way too long and have way too many scars and way too many stories. So hopefully we'll get some good stories. We'll get some good engagement here. So I'm going to ask them to tell a story. They each sort of been warned that they needed to come up with a story. So I'm going to work through my list here, ask questions in a somewhat random order to get them to tell their stories, and then we'll take questions. So do start typing your questions. Don't feel you got to wait till they shut up before you ask a question. You can go ahead and put them in now. So why don't we go ahead, Alan, why don't you go ahead and get us started with a story? Preferably not on mute.
Right, thank you. You asked for a story involving ML.
Right.
I wanted to show how it touches real lives, and this is a project I was really pleased and proud to be a part of. We work this FICO working with Vodafone. Vodafone operates a mobile money service called M-Pesa. Pesa is the Swahili for money, and it's mobile money, and it operates in 7 countries in Africa. And there are a lot of people in Africa who are not banked, but do have mobile phones. Now, these people depend on these money services for ordinary transactions, for accumulating money and spending it with local merchants and so on. People like this find it very hard to get small amounts of credit. Okay, they have no credit history. Banks aren't interested in lending them small amounts of money because of the risks involved and the low return. So what we did with Vodafone was to create a new scoring model, which is based entirely off their phone usage and the usage of the account on their phone. So and then we set up a marketplace for banks, local banks, where the banks could compete to offer small loans to people who apply for them through their phones. I'll give you an example of the situation. You might have a farmer. He's got his crop. He wants to take it to market. He needs to borrow $10 for a truck to take his stuff to the marketplace. He can then sell it and he can pay off his loan. That's the sort of scale of things we're talking about. That person can ask for $10 in his phone. He can get it into his account, in his M-Pesa account. He can pay for the truck using his phone, and off he goes. And it really transforms people's lives. So there you are. That's my story, just about how ML can be genuinely helpful for people.
Fabulous. Yeah, as you say, changing people's lives one very small loan at a time. So yeah. Excellent. All right, Guillaume, why don't you go next? I think you had a story you were going to share from that I heard you talk about just recently.
Yes, exactly. So I presented yesterday for those who could attend about a financial institution that is actually combining ML and rules to take decisions about fraudulent credit card transactions. And it is very different from the story that I talked about last year. Last year, indeed, as you mentioned earlier, as you alluded to, I talked about Mayflower and how we combine ML and rules. So here again, it is a case of ML and rules. There's a slight difference, though. I mean, there are a couple of differences. The first one being that this is a project that started in 2016, something like that, or 17, if I remember well. And at the time, we didn't have native integration, right, between rules and ML. So it was a little bit harder to make it work. That customer was actually an early adopter of the concept of blending ML and rules. The other thing is that on the Mayflower, we take 1 decision per second. And the decision is like a few hundred rules. It's not that much in terms of processing power. Here, in the case that I'm talking about, the fraud detection, or actually trying to fight the fraud and detect the fraud and try to reject maybe some transactions that could be fraudulent, happens in a few dozen milliseconds, 1 billion times a day. So, I mean, we are completely at a different scale. We do that 24/7. It's critical for running the world economy, obviously. And it's a massive scale, and it's completely different than from the story I told last year. The two things, though, have something in common, is how they need to blend analytics data, perception data, outcome of ML model to give insight, to have data that is richer than just what is fed naturally into the system, data that can be interpreted so that a rule engine can later on decide on that data and steer the ship or decide on a transaction. So the key point here is that we do have this combination of ML augmenting some of the initial raw data to make it richer, to make it more insightful, and then rules taking a decision on top of that. And I think that's really something we should keep in mind in this business, that the ML part is quite important as well.
Absolutely, that enriching the data so you can make better decisions. All right, Carlos, you get to go next. What's your little illustrative story?
Okay, so I chose this year something completely different outside financial services for once, which is, financial services by nature, is one of the biggest consumer of this kind of technology, but there are many other areas. So in this particular case, it's power transmission and power distribution and essentially preventive care. So one of the key problems in there is that when you are purely reactive, the amount of money that you actually lose is, as a power distributor, if you want, is staggering, and you expose yourself to all sorts of lawsuits and to unhappiness from the customer base, etc. So the whole idea here is, how can we build an application that captures enough data so that I can preventively go and take care of equipment before it actually goes down? So this is a very complicated data fusion type of problem first. And that's a constant that we see in large decision applications, and it's a constant that we see everywhere. That's going to actually get worse and worse as you continue adding ML and we continue adding deep learning to this kind of application, which is that the amount of data you're going to deal with, the complexity of the data, how different how differently it updates, how clean it is, etc., is the key problem. So in this particular case, the data could come out of sensors on the equipment, either connected to the internet through IoT, or collected by trucks that go through the roads and activate their RFID communicators on the posts and the cables, etc. It could also come out of things like surveys done by drone, so that they can look at where the trees are, the state of the etc. etc. So you're capturing structured data, you're capturing image data. We're also capturing case, when people call and are unhappy, and even more than cases. And again, that's another thing that we see in anything that has to do with consumer, that most of the data comes now out of social media. So they're not going to contact you. They're going to go to I'm not going to name it, but some platform where they're going to go and complain, and that's going to be the way they do things. So in there, the principle was very first approach is to basically build what in the fraud world would be a profile manager, what elsewhere would be called a variable manager, or something of that nature, where we would keep track of the state and trends of variables and make it very easy for users to actually store things in there, modify things in there, track things in there, and do all that fusion work. That involves ML. That also involves, interesting enough, since we've been talking about large language models, a fair amount of that, and we use it essentially to extract structure out of unstructured data. So we basically say, if it looks like this, this is a structure I want to see at the end, and we basically train the model, or at least prompt the model that way, and we start getting essentially structured data out of it. And then we reason on it, and the reasoning is takes into account all that state and variable state, plus the company's inventory, the current allocations of workers, the environmental conditions, when is it going to rain, that kind of stuff, to automatically try to generate things like allocations of teams to do repairs, the purchase orders for any material that would be needed, the work orders, that kind of stuff, as well as directing the case management of the responses on social media. And again, in the LLM case, since we're talking a lot about that, it's essentially a rules-driven generation of prompts, which is actually quite an interesting perspective. So that's an interesting large-scale application. It helped, and I'm going to say this, that the guy who was in charge of all this, or he's still in charge of all this, is an ex, payments transaction fraud, the guy. So he understood the problem, and that's why he architected, or at least he geared, or he orientated the architecture to be something along those lines.
Yeah. We've had a couple of conversations that are nothing to do with financial services, but there is some ex-banker or some financial services person, and they do think about the world differently because of their experience with machine learning and rules and so on. Sure.
One piece that is present there that we haven't talked about too much during this session is streaming analytics. There's a fair amount of that also involved, because again, the volume is just staggeringly high. So it's not like you can really store every data point. You really, in certain cases, you really need to store trends, and that's where the streaming analytics plays a significant role.
Sure. Cool. All right. Now, as you say, nice not to have a financial services example. All right, Gary.
Yep.
You're up next. What's your little illustrative story? We're starting to get some questions here, but again, go ahead, put your questions in the Q&A. We'll get them queued up.
Well, James, when you gave me the prompt for sort of a customer ML story, I was drawing a blank and was on the verge of hallucinating, like my good friend ChatGPT. So I thought I would just maybe recast some of the things that I learned or that motivated me to do the recent research with ChatGPT. And it kind of, in a way, goes back to Feel, which I think, in a way, goes back to what was your book, Smart Enough Decisions?
Smart Enough Systems, yeah, a long time ago. Right.
So it's kind of a tongue-in-cheek, right? There was a lot of during the early days of DMN, there was a lot of arguing and good-spirited debate on should we have an expression language at all, right? And it all sort of came down to, it'll never be friendly enough. And so I thought, well, let's just call it friendly enough expression language and leave it at that. But of course, no formal language is really going to be friendly enough. And I've always felt a little bit bad and somewhat, I guess, responsible for that. And I didn't
We certainly blame you for it.
And I didn't see much of a way out of that until, of course, the world flipped on its head, almost a year ago, and we got these large language models, into common use. And I think now, certainly natural language, I don't know how you can be friendlier than that, right? And so that sort of prompted me saying, what if you could just write your decision logic and maybe even some other things, in natural language. And so I started playing around with, some of the earlier versions, the 3.0 and then 3.5 offered a lot, but, certainly plagued by these hallucinations, and it would just give you all sorts of gibberish. And, it wasn't until I think I discovered that if you have it generate something that's independently verifiable and verified. I wrote a joke down here, so I'll go back. Ross said that, I guess his assistant calls, the LLMs, what was he said? Incompetent secretaries. I sort of think of them as politicians, right?
They may make things up at any moment.
What the stuff that comes out of their mouth sometimes can sound amazingly realistic and, sometimes even honest and true. But
Boris.
It really needs to be,
Boris is a kind of politician.
Yeah, it needs to be independently verifiable and verified, right? And you need to sort of do this as a matter of course. And so that's how, when I discovered that having it generate Python, the Python interpreter isn't really prone to hallucination. It's going to say, sorry, ding, ding, you lose, right? And the same thing with a JSON schema validator, right? Right. You can have it, you can beg and plead in your prompt to, please generate valid JSON. It'll say, by golly, I did, and it'll also say with Python, it'll generate bad Python, but you can verify it. And again, not that I, get any compensation from OpenAI, but I do think that their latest sort of code interpreter / advanced data analysis makes very good use of that observation, because they've kind of put that validation as an integral part of their processing loop, So yeah, it hallucinates, but then it discovers that what it said is garbage, and it revises it, quickly and in real time, and then shows you, a better result. So anyway, I guess that's my story of how I got into this and why I think it's very exciting.
Right. All right. And Jan, you get to go last because you just finished speaking. So you had a couple of minutes to rest your voice, but now you tell your story.
Thank you for that consideration. I really appreciate it. I've got to be careful what I say, because I've just realized I'm surrounded by vendors. So the case study.
We can't actually reach you.
You can. I'm sure you can. I'm sure you know a way. So the case study I'd like to
extend I can mute you.
involves fact-checking climate-related financial disclosures. I don't know if you've ever come across CFDs, but the CFD is essentially a statement which companies issue, which is a declaration of their commitment to meeting climate goals. And this is disclosed to investors and lenders and insurers and other stakeholders so that they can adequately assess and price the financial risk they're taking in investing in the company or insuring the company, and they can understand the likely financial impact related to climate change that's inherent with the company's policy. Unfortunately, these documents are very prone to what's called greenwashing, which is the tendency they have to try to evade the less convenient aspects of what they're doing and what they're forced to do. And we were tasked essentially with building a system to do two things. First of all, to supply a kind of, and these documents are unstructured, so there's no set format for them. The company can, as long as they set out their structure, they can choose any structure at all. And we were tasked with basically building a Q&A system which would be capable of asking arbitrary questions of these documents and detecting factual inconsistencies in them, detecting use of mitigated language, which is the attempt to hide certain obligations, the buzzword sequence detection, which itself is quite easy, and more importantly, the absence of key commitments. For example, the absence of a specific commitment to net zero timeframe. So we used Roberta and later GPT-3. And I think one of the wisest decisions I made was to forego using LangChain, which is what you might typically do to express pipeline that can do this kind of thing, and use DMN instead. And so we developed a decision equivalent of a retrieval augmented generation for the Q&A part. And Denise gone through that pattern yesterday, so I won't cover it again. But essentially, it's being able to anchor a question that a user may have by finding the most appropriate part of the document and then incorporating that into a prompt in order to direct ChatGPT or the GPT algorithm to give a relevant answer. And one of the reasons that embedding this inside DNN was so useful is because, by and large, the project documentation of machine learning projects is very poor indeed. It's often very badly distributed. It's got lots of moving parts. Most of them are hidden. And let's be honest, practitioners of ML tend to be focused on technical metrics and not the bigger picture of business value. DNN had turned out to be an excellent way of communicating with stakeholders exactly what we were doing. Mm-hmm. And we also used it to experiment with a number of what at the time was fairly new ideas. I think they've been discussed already in part, but even then, some techniques we used I don't think have been discussed so far at DecisionCAMP. One was prompt generation best practices, chain of reasoning, few-shot learning. That has been talked about. And representing that in DNN is actually remarkably efficient and quite compact. But what we were able also to use this environment to experiment with, better than LangChain, in my opinion, is anti-hallucination measures. In particular, measures we came up with, such as anchoring and voting, which are two techniques that I haven't seen widely used, but I have read papers on them and similar techniques, and also summarization. And all of these things are essentially ways of asking the model questions from different directions, and then canceling out the answer-specific hallucinations. And what you get is it tends to be much closer to the truth. But also we used decision modeling to cage models to actually, when we were using, for example, Roberta, we used it to detect those situations in which Roberta would be unlikely to provide a good solution, and we switched in another model instead. And one of the tests we were given that we passed with flying colors because of the front part of the DNN model, which does a joint distribution test on the input, is to detect documents we were given that were not CFDs at all, but were academic papers or a kind of bulletproofing test that they put out. I did have some findings that we got, some key challenges we had to overcome, but perhaps that best ties in with questions you're going to ask a bit later on, James.
I expect so. All right. Well, thank you, everybody. Hope that was a great set of stories. Nice wide range and lots of interesting things going on. So again, if you have questions, put them in the Q&A. We do have one, and it's addressed to you, Jamp, but I think it's one that other people will have something to add, so it should be fine. So what are your thoughts on the use of test data, not just to validate models and their boundaries, but potentially to identify irrelevant decision logic within models, and also in respect to the relevance and sensitivity of KPIs? And how do you see test data in those circumstances? Do you see that as a viable thing? What's your thought process around that?
So this is one of those things where I think that we are probably within the grasp of a symbolic solution to this, but it's always going to retreat from our grasp. So I have to say I'm a big fan of using test data. I think it's underused. I think it's even more important where you have models that have machine learning components, because you need, this business is a reputational business, right? We deal with a lot of clients who have very significant reputations on the line. So you're one hallucination away from really making making your clients look very foolish. And some of the hallucinations I've seen, and I'm sure the same is true for everyone else here, have been catastrophic in their stupidity. And sometimes when they're not catastrophic, they're dangerous in that they look plausible, but they're utter nonsense. So test data is hugely important. You need to be able to not only build your own, but you need to be able to generate it. And you need to be able to generate it systematically and ideally visualize the behavior of your system under a very broad spectrum of data. It helps if you can, as I mentioned in the last presentation, it helps if you can ensure that your test data is also full coverage, or as near full coverage as you can reliably get.
Yeah, you're waving, so you have something to add.
I mean, this ties directly into the presentation I made yesterday, related to when you mentioned earlier, Jan, about caging a model, about the reputation for delivering an outcome that is predictable and traceable. That's exactly what we're after. And one of the things that I was showing yesterday, I don't know if everybody got a chance to see it, was this capability to represent the call to an external model as a function, like I want to know about the propensity of a customer to churn, but then behind the scene use this model or that model based on which data is actually coming in. So to use a model that is relevant for this customer, for that transaction, because we know that models are trained on a specific set of data. They usually have metadata attached to them that are saying basically this model is good for this range of application, and people tend to just misuse them for any potential customer, client, transaction, whatever. So by caging them and using logic, we can actually select and detect if a model has been used outside of the range, and that goes right to the point you were making, and about the reputation and the fact we need to deliver predictable outcome, and that it becomes even more important that now that we're blending ML models, which look like black boxes.
Now we were putting politicians into our models.
Indeed. So Guillaume, so you're talking about taking essentially the data you use to train the model and reflecting that in your test data, right? So that the test data essentially knows what's the,
it's not just that. It's also the fact that quite often you have models being built by data scientists, right? And the data scientists are going to use their own view on how to extract the relevant production data to train models.
They're not robust. They're not robust.
They're not necessarily robust. And let's assume that models are documented properly, okay? Now, the people who are building the decision model.
Why on earth would we assume that?
Yeah, just for that conversation. It's not a general statement. But the people who are building the decision then are going to use test data to test that decision, right? And the test data may have a wider range than what the ML model has been designed for. So even though you're exercising a decision that under the hood uses a model, if you use a model outside of its range, it's hard to see, right? And that's why I think caging them, like you say, framing them, making sure that each model is used for its own relevant data, even though they all come up with the same function, right? You may have different models, based on different population for expressing the same function that is part of your decision. I think that's kind of key to make sure that we don't use them out of their range and leading obviously to irrelevant results.
So I'm gonna add something to this question, and I'm gonna ask Carlos, Alan, and Gary perhaps to chime in. So one of the things we often find when we're looking at this is when you get into a decisioning piece, there's a set of things that must be true that you can test, like their boundary conditions and so on. But there's also a lot of places where there's a wide range of what's allowed, right? You could say a minimum credit score is X, or you could say it's Y, and as long as it's a number in that range, the system ought to work. And it's a business choice within that range. And so how do you help customers see the difference between test data, where you're testing boundaries, making sure it's not broken, and data for simulation and for impact analysis, where really there's no right answer or wrong answer. It's just a question of how much money you are putting at risk or how risky a strategy you have. And do you find that customers struggle with thinking about those two things as related but different concepts? I'm just curious if any of the folks who have got simulation capabilities and impact analysis tools have had that. You know, we have this discussion with a lot of customers, and it can be an interesting one sometimes, that they want to test exactly as it is now, and they're like, well, that's not always what you want to test. Carlos.
Yeah, yes, we're intimately familiar with that problem. And you know, that's why, you know, we have simulation and testing built in as a platform, you know, from the day one, and even before you write rules, you write the KPIs. I mean, that's the principle. But going back to this, I think it's a question of how crisp your KPIs are. Mm-hmm. So a boundary in or out is a Boolean thing. You know, yeah, it passes. No, it doesn't pass. But then you go into the, you know, what's the percentage, you know, the distributions, and then you talk about distribution of dollars per geography, etc. So all those are metrics, are business metrics. What we see is not that much a difference in somebody needing to be explained the less crisp one, you know, the more simulation-based one. It's more the role. So if whoever is going to be writing the rules happens to be somebody who comes from the software world, they understand unit test. They understand something that tells you a 0 or a 1 or a true or a false, to be more precise. So as long as you can articulate your metrics in such a way that at the end of the day, it's a pass or a no pass, they're going to be happy. And they will work with it. If you talk to a data scientist, and again, I think we sort of dismiss data scientists a little bit too much. Data scientists know a lot about their data. They're very careful about their data. They clean it. I mean, it's incredibly well thought out. What is not good is later on the fact that there is a disconnect between the data used for them and the data used in production, and not the least of them being that when you deploy a model and you start doing what you guys call caging, or you start basically, or even more simply, if you have a decision in which your model only participates to 20% of what happens, it only sees 20% of the data. And if it only sees 20% of the data, how good is your measure? That's a big, in terms of their performance, a big problem that needs to be sorted out. We use a particular type of notion to do that, but what I'm trying to get at is that when you come from that data science world, you're going to be interested much more by the very soft and very fine-grained measures on your decision. And you're going to also be interested in much larger aggregates. So whereas your unit tests could be, a few tens of thousands of cases, your simulations are going to be, hundreds of millions of cases. So they will run a different way.
Be generated systematically. That's true, but I'm not sure I would agree that caging is a weakness. Caging is a precaution against the models failing to extrapolate into a.
Yeah, don't get me wrong. I'm not saying it's a weakness. It's actually something that's totally normal. When what you call caging, you can generalize it by saying in a decision, one of the branches will execute the model and the other one won't. Which is a more general approach. That by nature means that by default, if you measure the data that gets to the model at the point where the model gets the data, and you measure the outcome that way, only measures the data that went through that model, doesn't measure in terms of performance of the model, doesn't measure the rest. So you're not comparing the same metric, with respect to what the analyst did.
I think the performance, but the idea of caging is that you want the performance of the ensemble, not necessarily individual members.
I get it. But in your discussion, that's precisely the problem. When you're a decision person and you're talking to a data science person and you're talking about a metric, that's exactly the problem. Is that you as a decision person are going to measure the performance in this branch. This guy wants the performance throughout, and they're not the same. They're never going to be the same unless all the data passes through the branch. So that creates a disconnect in the discussion. And I think that's the biggest challenge that we have when we start incorporating that we as a profession, as decision management people, is that to establish a common language on those things with the data scientists so that we don't talk past each other. That's the key to it, in my opinion. And just to add, where I think test data, we don't have a sole solution for test data for language models, for large language models.
Oh, right.
So because it's in particular because we're not masters of the algorithm, and the algorithm changes. So you've tested like crazy on version 4 and they come out with version 4, that may change your answers.
Sure.
So that's a problem that we faced in that application that I was mentioning. I don't think we really have as an industry a solution to the problem of how do we test really a language model.
Right. Alan, I mean, I'm curious. I mean, one of the things that comes up when you get into the simulation piece is this whole, how do you get from testing to simulation to optimization, and then back to the sort of, how do you feed optimization into this discussion as well? I mean, what's been your experience? I mean, test data is, as we said, from a software point of view, is a relatively simple concept, right? I got to say, test data may be hard to do, but it's not hard to explain. But when you start getting into, well, what's a good enough data set to simulate the business impact or to do optimization? And then it starts to get like, okay, now it starts to get a bit gnarly, right? So what's been your experience with helping people think through this?
I thought it's interesting, actually, this conversation, because the question was clearly about test data, and we've been talking about anything but, really. The traditional use of test data is where we've got a well-defined system and you've got to verify that it's doing what you think it should do. But actually, of course, that's only quite a minority of the work we do in AI nowadays. So we use data for building our AI, so with machine learning and so on, where the data isn't test data, it's training data, and then on the level above, where we're dealing with the whole system in operation, and we want to define what it should be doing, we're talking about metrics, which, as I said in my talk, are intended to state what the purpose, what the purpose is, what the business values are, what the societal values are that we want the system to achieve. So we've got all of those levels. The data can be real or it can be synthetic, and there are different roles for different types of data. So all of our technology is swimming in data. Okay, it's become the medium in which we work. However, I do not want that to be seen as a justification for this data-driven phrase that makes me recoil every time I hear it. Our systems should not be driven by data. They're driven by by the motivation of these systems. What value do they bring to the organizations who deploy them? So it's top down, not bottom up, and the data are used to measure those things, or to create our ML, or to test our rules, or whatever. But we have to pick those data very carefully. And I agree with all the comments about data scientists. They're worth their weight in gold, because if you're going to do this sort of thing, you have to do it properly.
Yeah, and I think to Carlos's point, the intersection of how do you get programmers and people who are not data scientists to think about their data. I often say we as IT people tend to think of data sort of horizontally. What are all the fields? What are the allowed values for each field? As a data scientist, you tend to look at the data set vertically. So you might say, well, there are 97 possible values in this field. Yes, no, and 95 error conditions. So I'm going to regard it as having 2 values and some bad rows, because really only the yes and the no matter. The 95 error conditions are irrelevant, right? And as an IT person, you're like, no, there are 97 values. 97 values are allowed in this field. But a data scientist is
That's
like,
that's an
no
additional
one
use
cares.
of test.
Like,
It's an additional use of test data, of course, in that you're right. Data scientists tend to have a distribution-oriented view of data, but that's where large data sets can help you, because you can visualize the output distribution of your system, and sometimes that can provide striking clues as to where it's malfunctioning. You get voids or dents in the clustering of the data, which show that you've got issues you may not have otherwise realized.
So back to
I think
the
data
question.
scientists have an interesting horizontal perspective as well, actually, in this business about ethical AI, where companies know that they can't use age or gender or race in their models, right? So I think if they just exclude those columns from the data, everything will be fine. But of course, it's not, because because the ML is designed to find these connections, and it will find them.
Find proxies. Yes, exactly.
Exactly. You have to be very, very.
People say, "Oh, we're not using PII. We're just using zip +4 age and age range and gender." Like, so how many 70-year-old women do you think live on my block? I mean, the answer is 2, but it's like not really. You're getting pretty specific here, right? Anyway, no one's putting questions in the Q&A, so I know this bunch of troublemakers from old, so I'll ask them questions. But if you have a question, go ahead and put it in the Q&A. And I have a question. I'm going to start with Gary, as he's been slacking off and been quiet here. So I have another question for you, Gary. Think about LLMs. It seems to us, in our work around LLMs, so there's 2 potential ways to use LLMs in decisioning systems. One is, if you like, in a transactional context, as part of the interaction with a specific decision being made by a decision engine, or as part of a specific decision. And the other is in this sort of design metaphor, right? Helping me build the decisioning system in some way, right? What are the rules? What should be in? Do you think they're both equally good use cases? Do you think you see more potential in one or the other? How do you see these 2 threads? Because when people say, "Oh, how do you use LLMs with decision models?" my head goes to, how do I use an LLM to talk to something that's been built with the decision model? And other people's head goes to, how do I use an LLM to build a decision model? And they're both use cases, and I'm just curious what you think of them as examples. Then we let everybody else chat as well.
Sure. Yeah. So I'm using it at runtime, right? Is I think that's maybe more intuitive is what people think of, but it seems to be more dangerous in terms of prompt injection and hallucination. Keeping it grounded to the facts and not wandering off. Also, from a practical point of view, whose LLM are you using, right? If it's proprietary, you've got to, pay a fraction of a penny for every token, right? Whereas, looking at the, kind of the design time use, at least for now, right? When ChatGPT generates a Python program for me, I can run that program, it's mine, right? I can run it as many times as I want for free, right? I don't have to pay them any money. So that seems to be pretty compelling. But the most compelling thing
at the moment,
exactly, at the moment. In fact, you check their contract and it's there, in black and white. I checked it, but whatever our models produce is yours and royalty free, right? They do have that explicitly stated for now. But I think it's harder to get a hallucination past, like I said, a Python interpreter or a JSON schema validator. And so for me, that is the more interesting use at the moment. But certainly, things like that people used to worry, like I think we had to talk about sentiment analysis, right? There's just a lot of translation into different languages. There's so many use cases you can think that might be innocuous, right, for employing an LLM services at runtime, for kind of conditioning the input, for pre-processing, for post-processing, to find out, what's the current weather in a certain place, right? They can sort of, say, oh, I need to make an API call to do that. It can do it. It can format the information fluently and get it back to you. Those kind of things are great. But, actually asking it, so here's the credit score, here's their loan application, how much can I charge them, or will they pay me back? That's a little more dicey.
No, I wouldn't do that. No, it was a great comment made at an event I was at. and this guy said that his theory is that in an era of large language model chatbots, either your interface is going to be as easy to use as a chatbot, or it will in fact be used by a chatbot. Because if your interface is harder to use than a chatbot, someone will simply program a chatbot to use it.
Yeah, yeah.
And so as a software company, this is a slightly terrifying prospect, but it's like,
I think these, what do they call them? Co-pilots now, right? But
right.
I'm not sure if you can trace it back. I sort of blame the Microsoft Clippy, as starting that meme, and so maybe the current LLM powered chatbots will finally make Clippy useful.
Well, it's been estimated, I think, that all the consumers and producers of material on social media, particularly media like X, will soon be LLMs, because people will be mass producing input to the social media using LLMs, and people will be consuming it and aggregating it using LLMs. So there'll be no direct interaction.
There was a great cartoon of like someone saying, "Oh, I found this great LLM, and it will take my notes and turn it into this really nicely formatted email." And then the other half of the panel is someone going, "I found this great LLM. It will read this email and tell me what the key bullet points are." Yeah.
We can all go fishing.
Exactly. Yeah. Yeah. All right. We got another question coming in. Let me have a look here. I think I just got one come in. So, all right. So, Marlon asked, could we imagine the situation where we're about to make an automated decision based on machine learning, LLM, clean data, and everything else, and the decision owner is no longer able to understand even with a full explanation? So you get a loan, and there's a long explanation that theoretically explains how this decision was made and how the data was created by the LLM and yada, yada, yada. But even the subject matter expert doesn't really understand what that means. In other words, there's so much machine learning, LLM, generated data, and everything else that it's no longer possible, even for a relatively expert person, to understand the experience. Do we think that's a risk? And I had a sort of a caveat to it. And what happens when we've been using these systems long enough that there's no one left in the company who remembers how we did it before the machine did it? So there may, in fact, no longer be such a thing as a subject matter expert. That isn't another LLM. Anyone worried about this? To see this as a trend, or I mean, for the moment at least, I would say we're mostly seeing explanations. You can.
That's already happening. I mean, just take fraud. The number of neural nets involved in frauds. Nobody's going to explain a neural net. I mean, I know there are lots of patents out there to try to explain them, and there's a number of technologies involved. But by and large, a lot of these models are not explainable the normal way, if you want. That being said, there are domains where there is law that applies. So you can actually not put out there an automated decision system that you cannot explain.
Right.
And you have to explain it to a lawyer. So the question is, how do you explain it to a lawyer? So it could be because the lawyer is very good, but it could be because the approach that you took is an approach that's explainable. So basically, business rules, everything has to do with business rules is explainable. You have DMN, you have all those tools. The same thing could be said of a number of models. Scorecard model is typically and famously, a tool that is used to do that kind of stuff. There are also all sorts of tools that are being created right now to try to reverse engineer, quote unquote, and give you an explanation of a model which is not based on the model implementation itself, but on the inputs and the outputs. Those are or are not good. They require testing. It's yet another piece that moves. The problem with languages, on the other hand, and this I think ties also back to your other question, is that language is ambiguous. It's contextual and is ambiguous. So that's why nobody does mathematics in English. There is a formalism in place. So if there is an important need to communicate what you are doing in a way that's reproducible, that is somebody can take it and understand it without the need for further context, there has to be a formalism. And the formalism cannot be language, and not in the state that we are in today.
No.
So I do think we'll see a rise of actually LLM-based tools, among others, that are going to try to explain things, but I think it all flows back to how did you decide to actually express the logic in the first place? If it's explainable or close to explainable, you're going to get a check mark. If not, I don't believe that you will.
Yeah, and this is going to get worse. I mean, if you look at like Bill 64 in Quebec, the law there now says if you make an automated decision that impacts the consumer, they can formally request, like GDPR, like, what data did you use, and how did you use that data to come up with this?
That's not getting
conclusion?
worse.
And you have to do it in French.
Right. I mean,
and you have to do it
yeah,
in French.
More extreme, right? Yes, right? And you have to do it in French, right? Yes. And one of the interesting things about this, we were having this discussion with the Canadian Bank, and they were like, "Well, we never say no automatically for mortgages, so we're not going to have to explain it." And I'm like, "No, it doesn't work that way. If it's Friday afternoon and I'm bidding on a house, and you say, 'Oh, I can't decide automatically. You have to call me on Monday.' It doesn't matter if you say yes on Monday. I lost the house." Right. So I was negatively impacted by the fact that you couldn't decide a yes now. You had to defer the yes until Monday. And so I think people are going to expect to have every explanation, even referrals to humans, explained to them. And I think they're going to have an absolutely cast iron legal case that they deserve an explanation for that too. And that brings up the fraud question, because we have historically got away with not explaining fraud decisions, right? Because it's just a fraud risk. But now I think this is all going to put the cat among the pigeons, as they say, and it's going to be interesting. You know?
you've triggered my tip for 2024. So I'm gonna just come out with it now because we're close to the hour.
So when we start with,
we're never going to get more relevant than this. But,
right,
but essentially, I totally agree with what what you just said. Regulatory authorities are going to be pushing for interpretability. By the way, great question, Marwin. Regulatory authorities are going to be pushing for ever more stringent requirements for this. And I have to be blunt with you, LLMs can't do this. They have no reliable means of interpretability. If you think chain of thought and other prompt tricks are going to save you, you are wrong. And if you want a wake-up call, read the paper by Miles Turpin, very educational. Not only do all the attempts they made to get LLMs to explain themselves not work, sometimes the answer they generate and the explanation they generate for it are not consistent. In other words, they propose they propose an explanation which explains another outcome other than the one they actually came up with. So I am beginning to think, and this is something I'm going to be watching in 2022,
or even 2024.
is the only way around this, 2024, I beg your pardon, the only way around this essentially is to get around this jailbreaking problem, this unpredictability, by considering the strategic use of mechanized interpretability. And so this is something. Go read some papers about it. It's very early days for it. It's a fairly new idea, but I think it won't be long before we, by law, have to insert mechanized interpretability probes into our DNM models.
And I think it's also worth pointing out that many of the so-called explainable libraries from other kinds of machine learning models are not actually explaining what the machine learning model does. They're coming up with a plausible explanation of what the machine learning model did. So at some point, it's not obvious that passes the Bill 64 test, right? I don't want a plausible explanation of why you've turned me down. I want to know why you turned me down, right? And that's a different question. So I think that's
there are ways around that, and in FICO we already value explainability over predictive power all the time, and we will take a model that's been trained to be very precise and has some strange obscure mechanism, and we will use that to train an explainable model.
There we go.
So we use the explainable model in production, and I think I see LLMs as the mechanism for explanation rather than things that need to be explained at the end of the day. As long as we have some formalized, as we said, structure in which our decision making and the results it produces can be expressed, which the LLM can then look at and describe in accessible human terms in a way that's sensitive to the person who's asking for the explanation, then I think that's where LLM is going to be really useful.
And as Jan pointed out, we're into the last few minutes here, so we're going to transition to your final tip. So, Alan, is that pretty much your final tip?
Yes, that'll be
Looks
my
pretty
final
close
tip.
to it. That would be your final tip. All right. So, Carlos, what's your last tip for everybody? One tip for 2022.
Just
Right,
one.
Jan.
Just mind your data. That's all. That's all I can
mind
say.
your data. There we go.
It's all about data at the end of the day, and your decisions are going to be as good as your data is, as your ability to collect the data, to manage it, to version it, to keep track of it, etc. And the more you track, I mean, data storage is free, quote unquote. I mean, I'm exaggerating, but not far from it.
Not by much,
So
yeah.
do everything you can to basically capture everything, and then make sure that you manage it properly. Then the rest will come.
All right, and I think that the only thing I would add to that is just as an observation, which is like, but don't assume you need data to make a decision until you've actually built the decision model. Because I don't know about the rest of you, but every time we build a decision model, what people tell me they needed to make the decision, they are never, ever right. There is always at least one piece of information that they were sure they needed to make the decision that turns out to have no role in the decision at all. And there's always at least one piece of data they were sure, that they forgot to mention.
I think that's the most controversial subject that maybe we could address. I think the reality is somewhere in the middle. You need to pay attention to data. Of course, you need to pay attention to the decision, and they both touch each other, and they touch each other at the data. So that's the point.
All right, Gary, what's your final tip?
All right, so I got your request, right? You asked for a bio, a story, and a final tip. So I put that request into the chat section. I put the couple of paragraphs from LinkedIn of my resume into the chat session. And I put just the abstract of my presentation into the chat session. And finally, I said, give me a sort of a self-referential do or don't, right? And I had to edit a little bit of what it said, but this is actually what it said for the do or don't generated by ChatGPT. It said, let AI take some of the tasks off your list. Just as you've seen with this piece's creation, effective delegation to AI can elevate your efficiency and outputs, allowing you to focus on what truly matters. So
all right.
On the words of the robot itself.
Yeah, so Jacob, so next year we're inviting Gary's LLM to come to the panel, okay? Not Gary, just his LLM. All right, Guillaume, you get to make the final your final closing comment here.
Yeah, okay. So in fact, I was thinking about the question from Marwin and the answer from Carlos, and I do agree with that answer. That is, it's not really the fact that there is ML in the picture, it's how you model your decision that matters in the first place, right? If you model it to be explainable, whether it does contain ML models in it or not, it will be explainable. And that's why, and in fact, we have a change here, is that the rise of ML models gives focus to explainability, which people maybe sometimes overlooked in the past. So if I were to give a final tip in one sentence, I would say really start your modeling with a decision modeling from the top. You're going to derive what data you need from that. If it comes from an ML model, fine, but start with the decision you want to take and make sure that your model is sane and explainable first.
And you'll get no complaint from me on that one.
Yeah.
All right. So, Jan, Gary, Carlos, Alan, Guillaume, thank you all so much. That was terrific as always. Hopefully everybody enjoyed that as much as I did. Jacob, over to you.
Okay. Thank you very much, everybody. You did not answer question from Ron, who actually is right that if if natural language is sufficient, let's say for lawyers and for normal people, why it's not sufficient for decisioning systems, but it probably opens another discussion and we don't have time for this. But
there will be no lawsuits.
We will.
lawyers make money when you misinterpret. That's why.
No, but
Objection.
I think still we need to address this question. And what I also want just to summarize that a lot of questions what we discussed, they are valid for any community, for people, Andrew NG, Lagoon, and all people who is really involved in development of LLMs, but we have unique advantage as a community or decision management community. We already have a very strictly defined infrastructure. Like, for example, James yesterday made a very important point about documenting something even when we don't have it yet. For example, machine learning projects, but we do know where to apply and what to apply. Do we want to generate this particular sub-decision, and then we will know who generated this, and we know that this it's responsibility of this sub-decision. We have specific terms, we have specific organization of what decision is about, and so it means it's our advantage, and hopefully next year we will see more specific questions. This year it's first time, everything changing quickly, but if you listen to even today's presentation made by Tom and Denis, when they have this evolutionary approach and they accept that everything changes so quickly, but you cannot ignore it, but at the same time you need to find the right place where to apply it. So hopefully time will show, and I have feelings that with our existing environment, what actually works in real world, we have much better environment for applying these new technologies. And if please continue to write your answers in the Q&A. We still have one day tomorrow, and I want to thank everybody for this, for your answers and for your questions. See you all tomorrow. Thank you very much.
Take care. Good night.
Bye.